Hi, in this video, I'll explain how to connect an ultrasonic sensor to an Arduino board to find the range of the object or to find the distance of an object. You know that ultrasonic sensor has two slots here. One is used for transmitting the signal, other one is used for receiving the signals. So you have a pin for power in, and also you have a pin for sending a signal, and also there's another pin for sending and getting an echo, and also we can connect the another pin for ground. So here you have the slots that is separately discussed here for to know the operation. So you have a receiver and I have a transmitter. So initially what a transmitter does, transmitter sends a signal in the form of waves towards the object. Okay. So if there is any object here, so the signal will get reflected back to the ultrasonic sensor, which will be captured through the receiver. So this is original signal that we send by the transmitter, and on the other side we receive the echo signal, and that is going to be received by this receiver part. So using this transmission of the wave, we can find out at what distance the object is located. So that's what we call as a range finding using ultrasonic sensor. So in order to do this, what we do, we just do one simple calculation here. So as you know that the sound of the speed is given as 340 meter per second, which is also represented as 0.034 centimeter per microseconds. Okay, and the distance can be computed by using a relation. Distance is equal to speed into time divided by 2. Okay, why it is divided by 2? Because we are going upwards and also the downwards. That means we are sending the signal and also we are receiving the signal. So actually we are able to find the range of the object by using any one of the signal. So very particularly the echo signal. So it is basically a one way. So that is why it's divided by 2. Okay. So distance is equal to speed into time divided by 2. Okay. So now let us see how to develop a program for this. So we use a variable here called inches of integer type initialized with the value 0. Then we have another variable centimeter. So that is initialized with the value 0. Okay. Now we develop a function here. What function we develop here? It is basically a read ultrasonic distance. So this read ultrasonic distance will receive two variables as an input. One is int trigger pin as an input and int echo pin as an input. Okay, so two parameters are going to be taken into this function, and also this function is going to return a data type of long type. Okay, so now here in this we specify that the trigger pin. Okay, so trigger pin is going to be an output by using the pin mode configuration. And next, what do? We write a low signal onto the trigger pin. Then we delay the process for 2 microseconds by using delay microseconds function. Then we write now the high signal onto the trigger pin. So low to high pulse is developed here. Then what do? We wait for 10 microseconds. So after 10 microseconds, what do? We make the trigger pin low. That means we're going to send a signal here. So next, what do? We configure the echo pin as an input. So then what do? We use, as you configure the echo pin as an input, the signal is started receiving here. Got it? So we write high on the echo pin, and here what will happen here? This is basically a function called pulse ln. Okay, so in the pulse ln will give you a length of the pulse. Pulse ln will give you the length of the pulse. So how far this is high? Okay, how far the echo pin was high will be returned by using this pulse length. So which is basically a type of a long data type, and that's going to be returned here. Okay, so then what do? That is, we'll close the function. Okay, so this is a simple function called read ultrasonic distance. Now we see the setup. In the setup, we use a serial communication to display the range values. Okay, so serial communication is initialized here. So with the value with the baud rate 9600. Then the loop function started here. So in the loop, we specify the formula to find out the range in centimeter, to range in centimeter. So first, what do? We get the value from read ultrasonic distance function. We get the value from read ultrasonic distance function, which we have discussed already here. So from here, now we pass number 77. These are basically the pin number. 7 is the pin number. So what will happen now? The function will go from here to, okay, immediately the call will go from here to this place. Okay. So the function gets executed. As the function gets executed, it returns the pulse width here. It returns the pulse width here. Okay. So as it returns the pulse width, so we will get the value in a long data type. So that is basically the length of the pulse. That's basically the length of the pulse. So that into the 0.01723, which is nothing but a time into speed divided by 2. Okay, divided by 2. So that is equal to centimeter. So we represent the 340 meter per square in um, centimeter per microsecond divided by 2. Okay, so that is 0.01723, and here into the time period, that will give us the distance. Okay, distance equal to time into speed. Okay, then what do? Then we convert the centimeter into inches. Centimeter into inches by dividing the centimeter by 2.54. Okay, so after that, now we use the serial communication for printing the inches, only the word inches on the system. Okay, on the screen. Then serial.print will give the inches value and the unit inches. Okay, and also we can able to print the centimeter by using serial.print centimeter. Then the print line command will help us to print the unit centimeter. Okay, here in the inches values will come, and similarly from centimeter the values will come here. Then if you want to continue the work, we are just delaying it for 100 millisecond. Okay, so now let us see how to simulate this and get the work done. Hope you all are able to see the circuit here. So here you have an ultrasonic sensor which is having 3 pin. One is connected to ground, and other one is called a 5 volt power supply, and the connected to 5 volt power supply. And the green line, it is basically a signal just for both transmitting and receiving. Okay, so I have a code that is developed here. So as you know that the code will show us the values in centimeter and in inches. Okay, so let us see that now here. So I clear this previous operations and I get the text version of the code, and it is basically an Arduino IDE sketch. And now what you do, you can do the simulation of it. Okay, so you can see that as you start the simulation. Okay, you can start the simulation. We can find that when I click on this, okay, when I click on this, I would be able to vary my range here. So at this point, the range is fixed at 33.8 inch and 85.9 centimeter. So that's getting displayed here, 33 inches and 86 centimeter. And if I keep moving it, so the period of the pulse is getting increased. So correspondingly, you will you can see the variation in your display here. Now it shows 82 inches to 10 centimeter. So we can increase it like this to as much as we want, and you can see the variation here. It's a simulation. Now it detects that an object is here, and that's getting displayed on the serial window. So as you vary your signal, as you vary your distance, both the transmitting signal and receiving signal, we can find the range of the device or any obstacles. Okay, so hope this would be useful. Thanks for watching. Hi, so in this video I'll explain how to interface an ultrasonic sensor and an LCD. So by using this circuit, we can able to measure the distance of an object. Okay, basically ultrasonic sensor is used to detect the distance of an object. Okay, so from the basics, you can get your ultrasonic sensor, and also previously you might have used the potentiometer, and the Arduino board is here. Okay, so right now the board is LCD is blank here, and also you can see that here potentiometer should be kept at maximum level to see the proper display on the LCD. The contrast should be increased, so the potentiometer should be kept at a maximum value. Okay, so I've done this program here to display the distance both in inches and in centimeter. Okay, so now let us run this program and see that. So I'm I just started the simulation here. So it's getting initialized now. So once the simulation is started, and now the LCD is ready for display. Next, what we have to do is we have to give the input for the sensor, right? So just click on the sensor. Again, there will be a blue cone kind of thing will be there. Okay. So by using this, we can, if I click here, the object is detected here. Okay. So we can see that the object is at the range of 88.5 inches and 224.9 centimeter. So you can see it in display. It is detected here 88 inches or 225 centimeter, isn't it? So as you vary this object target, you can see the variation in your display. So even in the LCD sensor also displays the value in inches, and even in the LCD we have written a program to display that. And to another extent, we have used the serial window also here. Okay, so by using the serial monitor also, you would be able to see the screen here, the values, whatever the value displayed here, the same value will be displayed here as well. Understand? So by using this, we can use ultrasonic sensor for range detection purpose. Thanks for watching.